Let's review what a Dockerfile is and how we can use it to create our own Docker images. Whenever you want to Dockerize your own application, what you will be using is something called a Dockerfile. Now, in Docker, a Dockerfile contains all the instructions that Docker needs to follow in order to build a new Docker image. As you can see in here, the builder, that is the process in charge of using your Dockerfile to build a specific Docker image, is using two different things as an input. It is using your Dockerfile containing all the instructions for Docker to build the Docker image, and also it is using the build context that provides the content for the builder to execute the instructions on. So what the builder is going to do, it is going to take the build context as the input content for building your application, and then once it has the content, it will apply all the instructions to this content in order to create the exact image that you want as a result. You can think about it like building a house, for example. In here you have the blueprints, you have all the instructions on how you can build that house, and then you have the materials. With both the materials and the instructions, you start building each part of the house. Once you finish doing this, you will have the house as a result. In this case, it is the exact same thing. The Dockerfile provides the instructions, while the build context provides the content for the builder to apply those instructions. Here in our example, you can see we have within this basics folder, we have a Go application. And as you can see, when we run the application, you can see the output missing HTTP server port using 8080 as default. So we don't have this environment variable, we will be using 8080 as default. And then about to start application, and here we have our working web server. So from here we can curl to localhost 8080/ping, and here we have pong as a response. If we see this with the verbose mode, we can see we have a 200 OK as a response. And you can see the request right here. You can do the exact same thing if you go to the terminal and you type go run cmd/application/main.go. You have missing HTTP server port environment variable using 8080 as default. Here you have our application up and running, and now you can curl from localhost 8080/ping. And here you have pong as a response. So we have a working web server in Go. So now in our example called basics, we can create a new file called Dockerfile. And you can see the moment we use this file name, we can see the Docker icon right here, specifying that this is a Docker file. Every Docker file will start with a keyword called from. This keyword defines what's the base image that we want to use for building our own Docker image. You can use a Linux image, a Windows image, you can use Go, Node, Nginx. You can base your own image on a lot of different images depending on what you are trying to do. In our case, since we are creating a Go application, we will base our own image in the Golang 124 image. If you use this tag and you search for Golang Docker image, you can see this official image right here, and this is the one we are using. You can Docker pull Golang, and when you do this, what you are doing is pulling this image from Docker Hub in this case, and we are going to use the tag 124. That is one of the tags that we have available in here for the specific Go 124 image. So with this line, we are telling Docker that we want to base our application in the base Golang image available in Docker Hub using the specific tag 124. With this, we can change the Go version that we are using. If you have a Node.js application, you will use Node in here. So you can change the base image depending on what you are trying to deploy whenever you run your application. In this case, the Golang image is based on a Debian operating system. So whenever we create a new image using the Golang base image, we are installing a Debian operating system and also installing Go on top of that Debian system. In this line, we already have Debian as the operating system, and we also have Go installed. Now that we have this, we are going to use a different keyword called WORKDIR. In this case, WORKDIR is defining our working directory. So whenever we start building the image, whenever the builder starts working on this image, it will be located in this folder we defined right here. In our case, we will use /application. Every time you see the WORKDIR keyword in here, you can think about it like doing create directory /application and change directory to this folder. The WORKDIR keyword is creating the folder if it doesn't exist, and also changing directory to this folder. So every command that we execute after the WORKDIR keyword will be executed in this folder defined within the WORKDIR. Now that we have our WORKDIR, we are going to use a different keyword called copy. With the copy keyword, what we are defining is what we want to copy and where we want to copy. This is copying everything from the build context and copying everything in our local folder. Remember that we are located in /application. So the copy using a dot here is saying copy everything from the build context and copy that in the folder where I am located right now. So what the builder is doing at that moment is saying copy everything from this content from the build context, copy everything into the /application folder where I'm located right now. So we are bringing the entire building context into the local folder. And since our building context will be the content of this basics folder, we will have CMD, package, Dockerfile, Go mod, the Go sum as well. So we are copying all of this into /application. Once we have the code, one thing that we can do is execute a command using the run keyword, and we are going to say go mod download. In this case, whenever we use the run command, we are going to execute a command on the operating system, in this case, go mod download. What we are doing here is telling Go, because you can see we are running Go in this case, and Go is available at this line because we already used the Golang image installing Go in the operating system. So we are telling Go that it should take a look at the module, that is this module right here, and it should download all the dependencies defined in this module. So we want to take all these dependencies and download them in the Go path that we have available in the Go environment right here. This is because since we are running a Go application, we want to download all the dependencies for our Go code. Now that we have all the dependencies available and we have our Go code, one thing that we can do is run go build. With this command, we are going to take Go code, we are going to compile the code and generate a binary that we can execute. So we want to go build, and we want the name of this binary to be called application. Now we can tell Go where the main file is, so it can use that main file to compile it and generate the application that we want to build. Now the last argument that we need to pass in here is where is the main file that Go should use as the entry point for the application that we want to build. In our case, since we have all this content right here, you can see inside CMD /application, we have main.go. So we're going to pass CMD /application /main.go. You can see if we go to our examples folder, this is the content of the folder that we have right now. If we execute go build and we pass application as the name of the binary that we want to execute, and then we tell Go that our main file is inside CMD application main.go, Go is going to take that entry point, that main file with the main function, and now we have this application. You can see it is an executable file that we can just execute and pass application, and we have our running application in there. We compile Go code and we generate a binary that we can execute, and this is our application completely built and compiled into a binary that we can execute. So that's exactly what we are doing in here. After executing this line inside the /application WORKDIR, we have a binary that we can execute. Now, as you can see, we can use this way for executing a binary. We are just passing where the file is and just executing that file. In the Dockerfile, we have one keyword called entry point. With this keyword, what we are defining is what's the entry point for our application. In this case, will be application because that's the binary that we want to execute. This entry point is defining to the Dockerfile what's the entry point for our application, what's the binary that Docker should execute whenever it runs the Docker image that we are going to create. Now, every time we execute a command like this, we can also pass arguments to this specific command. So we can pass argument 1 and argument 2, or we could pass flags like conf equals true or whatever. So you can see that we are passing arguments in here. So we are passing values to this command that we are executing. In our Dockerfile, we have a keyword for capturing all of this called CMD. Since we already defined our entry point as /application, in our Dockerfile, we could use CMD for capturing all the arguments that we are passing whenever we execute our application. So this is the entry point, and this is what will be sent to the CMD keyword in our Dockerfile. So you can see that with just this approach, now we can create our Docker image and run the application exactly as we were running the application using our operating system. But in this case, we are defining the instructions for Docker to follow in order to build our own Docker image.